Hello dear students, in this video I'll continue with the first unit, numbers, quantification and numerical applications. The next topic what we have is problems on boats and streams. First we will see some of the formula in boats and streams. If we take the speed of a boat in still water as x km per hour and speed of the stream as y km per hour. If the boat is moving along the stream, then we have what is called the downstream speed. So the downstream speed will be the sum of the speed of boat in still water and speed of stream. So if we take the downstream speed as u, we have u is equal to x plus y km per hour. On the other hand, if the boat is moving opposite to the direction of the stream, then we will have upstream speed given by v km per hour, which is x minus y km per hour. So if the downstream speed u and the upstream speed v, if they are given, then we can find x and y as, we can solve these two equations and we can have x and y as x is u plus v by 2 and y is u minus v by 2. So this is how we can find the speed of the boat in still water and speed of the stream when the upstream speed and the downstream speed when they are given. We know the formula for speed, it is distance by time. So these are some of the formula that we have to remember while solving the questions. Now these are the questions from exercise 3.1 of chapter 3 from class 12 applied mathematics by D Sharma. The first question, the speed of a boat when rowing downstream is 32 km per hour, whereas when rowing upstream it is 24 km per hour. Find the speed of the boat in still water and speed of the stream. So we just now saw when we know the downstream speed and the upstream speed, we can find the speed of the boat in still water and speed of the stream. So let us take speed of boat in still water as x km per hour and speed of the stream as y km per hour. Here the downstream speed u is given as 32 km per hour and the upstream speed v is given as 24 km per hour. So we have the speed of the boat in still water as u plus v by 2. So it is 32 plus 24 by 2, which is 56 by 2, 28 km per hour. And we have y as u minus v by 2. It is 32 minus 24 by 2, which is 8 by 2, 4 km per hour. Therefore, speed of the boat in still water is 28 km per hour and speed of the stream is 4 km per hour. Moving on to the next question. A man can row a boat 2 km against the stream in 20 minutes and returns back at the same point in 15 minutes. Find the rate of rowing the boat and speed of the current of river. So here it is given a man can row a boat 2 km against the stream. So here if we have 2 points, when the distance is 2 km, he can row a boat against the stream in 20 minutes. So if this is the direction of the stream, he can row against the stream in 20 minutes and he can row along the stream in 15 minutes. We need to find the rate of rowing the boat and speed of the current. So let us take speed of the boat in still water as x and let speed of current be y. Now using the formula, speed is equal to distance by time. We have the upstream speed as distance by the time taken to go upstream. So here the upstream speed v will be d upon t1, which is 2 divided by 20 minutes. 20 minutes is 20 upon 60 R. So this is 2 into 6 by 2, which is 6 kilometer per hour. And then the same distance it is covered downstream in 15 minutes. So the downstream speed U, it will be d upon t2. So the distance is 2 upon time is 15 upon 60. Because it is given 15 minutes, we need to have the time in hour, because the speed should be written in kilometers per hour. So this is equal to 2 by 15 into 60. So it is 8 kilometer per hour. So we got the downstream speed as 8 kilometer per hour and the upstream speed as 6 kilometer per hour. Now we can find x and y. We have x is equal to u plus v by 2. So it is 8 plus 6 by 2, 14 by 2, which is 7, and y is u minus v by 2, which is 8 minus 6 by 2. This is 1. Therefore, speed of the boat in still water is 7 kilometer per hour and speed of the current, it is 1 kilometer per hour. Moving on to the next question. A man takes 3 hours 45 minutes to row a boat 15 km downstream of a river and 2 hours 30 minutes to cover a distance of 5 km upstream. Find the rate of rowing the boat and speed of river current. So here we have one distance which is travelled downstream in certain time and another distance which is travelled upstream in some other time. So using this we can find the downstream speed and the upstream speed, and then we can find rate of rowing the boat and speed of current. So it is similar to the previous one. Here we have different distance and accordingly different times. So let us take, let speed of boat in still water be x kilometer per hour and speed of current is y kilometer per hour. We know the speed is given by distance by time. So downstream speed u is equal to d1 upon t1. Here it is given, he takes 3 hours 45 minutes to row 15 km downstream. So downstream speed is 15 upon 3 hours 45 minutes. So 3 hours 45 minutes is 3 plus 45 by 60 hours. So it is 15 by 4. So it is 15 upon 15 by 4. This 15 and 15 will get cancelled. So u is equal to 4 km per hour. And next we have upstream speed v. Here it is given, he takes 2 hours 30 minutes to cover a distance of 5 km upstream. So it is distance by time. Here the distance is 5 km and time is 2 hours 30 minutes. 2 hours 30 minutes is 2.5 hours, or it is 5 by 2 hours. So 5 upon 5 by 2, which is 2. So the upstream speed v is 2 km per hour. Now we can find x and y. X is u plus v by 2. It is 4 plus 2 by 2, which is 6 by 2, 3. And y is u minus v by 2. It is 4 minus 2 by 2, which is 1. Therefore, x is equal to 3 km per hour, the speed of boat in still water, and the speed of the stream is 1 km per hour. Moving on to the next question. A man can row a boat at 6 km per hour in still water. If the current of water in the river is at 2 km per hour, It takes him 3 hours to row to a place and come back. How far is the place? So here it is given. The speed of the person in still water is given and the speed of the current is given, and it is given it takes him 3 hours to row to a place and come back. We need to find the distance to that place. So here let the distance be d kilometer. So here the speed of the boat x is 6 kilometer per hour and the speed of the current y is 2 kilometer per hour. And then the total time taken to travel a distance of d kilometer and come back, it is 3 hours. So this downstream time plus upstream time, t is given as 3 hours. Now we know time is equal to distance upon speed. So here time taken to go downstream will be the distance downstream upon downstream speed. So it is d upon x plus y plus upstream time is d upon x minus y. This is equal to 3. Now we know what is x and what is y. When we substitute, we will be able to find d. So d upon 6 plus 2 plus d upon 6 minus 2 equal to 3. Or we have d, we can take it outside, 1 by 8 plus 1 by 4 is 3. This when we take LCM, we get 3 by 8. So d into 3 by 8 is equal to 3. This 3 and this 3 will cancel. From this we get d is equal to 8 kilometers. So the distance is 8 kilometers. So the place is 8 kilometers far. Or we can also use a general formula to find this d. Let me derive it here. D upon x plus y plus d upon x minus y is equal to t. When we have a question like this given, we can find d using this formula also. So it is d into 1 by x plus y plus 1 by x minus y. This is equal to t. So if we take LCM, we get x minus y plus x plus y upon x plus y into x minus y. So it is x square minus y square. This is equal to t. Here plus y and minus y will get cancelled. We get d into 2x upon x square minus y square equal to t. Or we have d as t into x square minus y square upon 2x. So using this formula also we can find d. When we substitute x as 6 and y as 2 here and t as 3, we will get d as 8 kilometers again. So we can find d using this formula also, that is the distance using this formula also. But then only when we get the sample paper and marking scheme, we can be very sure whether we can use this formula directly to find the value of d. If there is some step mark for all these steps, then we have to follow these steps only. Moving on to the next question. A man can row a boat at 7.5 km per hour in still water. If in a river flowing at 1.5 km per hour, it takes him 50 minutes to row to a place and back. How far off is the place? So it is similar to the previous question. So the time taken upstream plus the time taken downstream is given as 50 minutes. So let the distance be d kilometer. The speed of the boat in still water is given. It is 7.5 km per hour. So here x is equal to 7.5 km per hour. And it is given the river is flowing at 1.5 km per hour. So speed of the stream or speed of the river is 1.5 km per hour. Now the downstream time plus the upstream time, it is given as 50 minutes. We need to have a distance in kilometers and time in hours. So it is 50 by 60. So the downstream time it is nothing but distance upon downstream speed. So d upon x plus y plus d upon x minus y. This is equal to 5 by 6. So we have x and y. If we substitute, we will be able to find d. D upon 7.5 plus 1.5 plus d upon 7.5 minus 1.5 equal to 5 by 6. So d, let us take it outside, it is common. So d into 1 by 9 plus 1 by 6 equal to 5 by 6. So here the LCM is 18. So from this we get d into 5 by 18 equal to 5 by 6, or d is equal to 5 by 6 into 18 by 5. So we get d as 3 kilometers. So the distance, the place is 3 kilometers far. Moving on to the next question. A man can row a boat in still water at the rate of 6 km per hour. If the water in the river flows at a rate of 2 km per hour, it takes 3 hours more in upstream than to go downstream for the same distance. How far is the place? So here again speed of boat in still water and speed of river is given, but it is given it takes 3 hours more in upstream than to go downstream. So the time taken upstream minus time taken downstream is 3 hours. So using this relation we can find the distance. So here again let us take, let the distance be d kilometer, and here the speed of the boat in still water is given as 6 km per hour and speed of the stream is 2 km per hour. The time taken to go upstream minus the time taken to go downstream, this is given as 3 hours. So time taken to go upstream, we have distance upon upstream speed. So d upon x minus y minus d upon x plus y. This is equal to 3. So this implies d by 6 minus 2 minus d by 6 plus 2. This is equal to 3. Or d is common, it can be taken outside. D into 1 by 6 minus 2 is 1 by 4 minus 1 by 8 equal to 3. Now let us take LCM. So here we have 2 minus 1. D into 2 minus 1 by 8 is 3. Or d into 1 by 8 equal to 3, or d is equal to 24. Therefore, d is equal to 24 kilometer. So the place is 24 kilometer far. So this is the value of distance d. Moving on to the next question. A man rows a boat 10 km upstream in a river and returns back to the starting point in 55 minutes. If the water in the river is flowing at the speed of 2 km per hour, find the rate at which the man can row the boat in still water. So here the speed of the stream is given. We need to find the speed of the boat in still water. The total time taken is given as 55 minutes and the distance is 10 km. So let us take, let speed of the boat in still water be x km per hour. The speed of the stream y is 2 km per hour. And then the distance is given as 10 km. The total time taken to go upstream and return back. So the time taken to go downstream plus the time taken to go upstream, it is given as 55 minutes. 55 minutes is nothing but 55 by 60 hours. So this is 11 by 12. So downstream, time taken to go downstream is given by d upon x plus y. Using the formula, time is equal to distance by speed plus d upon x minus y equal to 11 by 12. So we can substitute d and y. Then we can find x. So d is common. Let me take it outside. D into 1 by x plus y plus 1 by x minus y equal to 11 by 12. D is 10 into 1 by x plus 2 plus 1 by x minus 2 equal to 11 by 12. So let us take LCM and simplify. Numerator we have x minus 2 plus x plus 2 upon x plus 2 into x minus 2. So it is x square minus 4. This is equal to 11 by 12. Or we have 2x by x square minus 4 equal to 11 by 120. Now if we cross multiply, we have 240 equal to 11x square minus 44. 240x is equal to 11x square minus 44. So 11x square minus 240x minus 44 equal to 0. Now we get a quadratic equation in x. If we solve this equation, we will be able to find the value of x. So here we have 11 into 44. So it is 11 into 2 into 2 into 11. Negative. So the roots are minus 242 into 2. So here we have 11x square minus 242x plus 2x minus 44 is 0. So it is a simple quadratic equation which has to be solved. So 11x into x minus 22 plus 2 into x minus 22 is 0. X minus 22 into 11x plus 2 is 0. So from this we get x is equal to 22 or x is equal to minus 2 by 11. Now this is not possible. Minus 2 by 11 is not possible, since speed of boat cannot be negative. So we have x is equal to 22. Therefore, x is equal to 22 km per hour. So we are asked to find the speed of the boat. We got x as 22 km per hour. Next question, a boat goes 8 km upstream and then returns. Total time taken is 4 hours 16 minutes. If the speed of the current is 1 km per hour, find the actual speed of the boat. So let us take speed of the boat in still water as x km per hour. Speed of the current y is 1 km per hour and the distance is given as 8 km. The total time, the downstream time plus the upstream time, the total time is 4 hours 16 minutes. So it is 4 hours plus 16 minutes is 16 upon 60 hours. So this is 64 by 15 hours, the total time taken. Now let us use the formula for D and then find the value of x. We have D is equal to T into x square minus y square upon 2x. So using this also we can find x. D is 8, T is 64 by 15 into x square minus y is 1 upon 2x. So this implies 8 into 15 into 2 by 64. This is equal to x square minus 1 by x. I am taking all these terms to the other side. So when we take 15 to the other side, we get 8 into 15 by 64 into 2. So this, let us simplify. So 15 by 4 is x square minus 1 by x. So when we cross multiply, we get 15x is equal to 4x square minus 4. So this implies 4x square minus 15x minus 4 equal to 0. So the factors are 4x square minus 16x plus x minus 4 equal to 0. So if we solve this equation, we will be able to find the value of x. So we have 4x plus 1 into x minus 4 equal to 0. So we get x is equal to 4 or x is equal to minus 1 by 4. Now this is not possible since speed cannot be negative. Therefore, x is equal to 4 km per hour. So the speed of the boat in still water is 4 km per hour. Next question. A man can row 6 km per hour in still water. It takes him twice as long to row up as to row down the river. Find the rate of the stream. So here the speed in the still water is given. So let speed of the stream be y. Speed of the boat x is 6 km per hour. So if we take the downstream time as equal to t1, then the upstream time t2, it is given as twice the downstream time. So it is given as 2 times t1. Now we know time is given by distance by speed. So here downstream time equal to t1, it means distance upon downstream speed. Downstream speed is 6 plus y. This is equal to t1. The upstream time t2, it is given by the distance travelled upstream upon the upstream speed. So it is d upon upstream speed is 6 minus y. This is equal to 2 times t1. So we can substitute t1 from 1. This implies d upon 6 minus y equal to 2 into d upon 6 plus y. This is from 1. So when we cross multiply, we get 6 plus y is equal to 12 minus 2y, or y plus 2y. 3y is 12 minus 6 is 6. So we get y as 2 km per hour. So the rate of the stream is 2 km per hour. Moving on to the next question. A man can row 1 by 3 km per hour in still water and finds that it takes him thrice as much time to row up than as to row down the same distance in the river. Find the speed of the current. So it is similar to the previous question. Here the speed of the boat in still water is 1 by 3 km per hour, and it takes him thrice as much time to row upstream than to row downstream. We need to find the speed of current. So let us take speed of stream or the current as y km per hour. Speed of the boat x is 1 by 3 km per hour. 1 by 3 is 27 plus 1, 28 by 3 km per hour. So let the distance be d kilometer. Then the downstream time t1, it is given by distance upon downstream speed. So it is distance upon 28 by 3 plus y. The upstream time t2, it is given, it takes thrice as much time to row upstream than to row downstream. So the upstream time t2, it is 3 times t1. Or the upstream time is distance travelled upstream upon the upstream speed. Upstream speed is 28 by 3 minus y. X minus y, x is 28 by 3. So it is 28 by 3 minus y. This is equal to 3 times T1 we have d upon 28 by 3 plus y. D upon 28 by 3 plus y. So d and d will get cancelled. We will be able to find the value of y. Let us cross multiply. 28 by 3 plus y equal to 3 into 28 by 3 minus 3y. Or we have 4y is equal to 28 minus 28 by 3. Or it is 28 into 1 minus 1 by 3. 1 minus 1 by 3 is 2 by 3. So y is equal to 28 into 2 by 3 into 1 by 4. So this is 14 by 3. Therefore y is equal to 14 by 3 kilometer per hour. So we get the speed of the current y as 14 by 3 kilometer per hour. I hope this video was useful for you. If you find this video useful, share it with your friends. If you have not subscribed to my channel, please subscribe. Thank you for watching.